Welcome back to Calculus. This is actually a calculus video after seeing so many pre-calc get posted. I'm going to do the last two examples from 5.7. I know that, let's try this, 5.7. I know that I've done a lot of pre-calc, and you guys are probably feeling like I'm leaving you out. So here we go, 5.7, examples G and H. Next page. Okay, so example G. This is the one that we did some of this in class. So, but it's a weird one. So I'm going to do it again. I don't think we quite finished. Plus 2 dx. Okay, so looking at this problem, kind of forward thinking. Denominator, I'm thinking arctangent. Well, we also, though, should think about substitution, because there's going to be probably some of those mixed in here, and in long run, like on the semester exam, you're going to need to know, is this a substitution problem? Can I do arctangent? Do I need both? So really your first thought should be substitution. You think, oh great, the denominator is second degree, the numerator is first degree. Let's do a U substitution. And you go along about your business, and you see that dx is going to be 2x plus 2 dx. Not exactly what you wanted, right? You wanted 2x minus 5. So there's really no way to, you can deal with numbers that are multiplied too much or too little, but not added or subtracted. So we're going to have to do something a little clever here. We're going to put 2x plus 2. We're going to say, I'm just going to make it 2x plus 2. But we can't just get away with that. We're going to have to pay for that. We'll pay for it right here, minus 7. Now check with me. Does that doesn't change anything? If you were to simplify the numerator, you get the same place you started. But the minus 7 allows you to have the 2x plus 2. But like I say, we pay for it. So the way we're going to do this is we're going to split this now. 2x plus 2 is perfect for the substitution we're about to do. And the minus 7, I'm just going to put it out front, is going to be really nice for, okay, got cut off a little bit there. And this minus 7 times the integral of 1 over x squared plus 2x plus 2 is perfect for completing the square. It's perfect for arctangent. But to do that, we're going to have to complete the square. You can think, gee, I really wish this was a 1 and not a 2. We'll make it a 1. But again, you have to kind of pay for it by putting your other 1 there. And if you divide these out, kind of group them differently, then you can see that the next step, I'm just going to go ahead and write this, we would have integral of 1 over x plus 1 quantity squared plus 1 squared dx. And over here, we can do our substitution. So this is going to be in terms of u, and this is perfect. The denominator is u, and the numerator, along with that right there, makes up dx. So you end up with 1 over u. That's pretty awesome. That's now natural log of u minus, over here, I'm going to write this, u is x plus 1. Just make sure we don't miss it. A is 1, and du is indeed 1 dx. And so we are set up. We're not actually doing substitution, but we're saying if we did, this is what we would do, and it's totally set up perfectly. So minus 7. Let's see, arctan is going to make it 1 over a, which is 1, arc tan x minus 1 over 1 plus c. Wow, I'm right at the bottom here. Guess I better go to a new piece of paper, a new sheet. So we end up with natural log of u, which we said was, oh, I should make that, no, actually I don't need the absolute values, but I'll put them on there anyway. Natural log, absolute value, x squared plus 2x plus 2 minus, we said 7 times 1 over 1, we don't need 1 over 1, arctan, it was x plus 1 over 1, we don't need the over 1, x plus 1 plus c. And it's true, I'm going to take these out now, that you do not need the absolute values. So we cut those off. Because the reason we don't need them is because x squared is always positive. Oh wait, yeah, x squared is always positive. 2 is always positive, and 2x could be negative, but if it's negative, it'll never beat out the x squared plus 2. If you didn't put it, it's fine. But if you graphed on your calculator x squared plus 2, it can't be negative. So we don't need absolute value. That's it. Tough one, but we can do it. Let's do one more. Example H. Thanks for sticking with us. Integral. This one we will do in class Tuesday, but if you're not there, you fine band folks and others, musical people, then you might want to check this out as you're doing right now. Okay, here's our setup. Strange, with a negative down there. Looks like arc sine, because there's a square root and there's no x out front. So I'm anticipating arc sine. Probably need to complete the square down there. Who knows what's going to happen? Let's just go for it. See what happens. One thing I don't like the negative. Let's factor the negative out. That's weird, but let's do it. Oops, I'm not factoring very well, am I? I really wish this were a minus. That's a minus. That factored the negative out. You could say, I really wish this was a plus what? What's that you said? 4? That's right. Really wish it was a plus 4. Keep doing that. But it's not a plus 4. So you have to kind of pay for putting it there. How do you do that? Well, usually you would put plus 4 out here. Or minus 4. But in fact, in this case, since there's a negative out front, right there, this plus 4 is in truth a minus 4. So to pay for it, we put a plus 4. And one way to check it is if you distribute the negative through, you would have negative x squared plus 4x minus 4 plus 4, which would get you right back where you started. So good. So we do have dx on the end. Don't forget that. Let's see. Let's rearrange this, because it's kind of unusual to have the negative in front of the positive. And it's going to be 4 in the front. I'm going to call it 2 squared minus, this is now a perfect square, this is x minus 2 quantity squared. This is looking pretty good. Pretty good. Because, well, one, we know in our arc sine, we have the a first, the protector, and that 2 squared is first, so this is looking good. If our u is x minus 2, then our du would be dx, and we have a 2 up there, so we have to deal with that. This is terrible handwriting. That's a du, by the way. I can't have that be like that. Let's just get rid of all that. Then our du is dx. Oh, that's so much better. And a would be 2, because the 2 squared. So we have this extra 2. I could, let's just change it right now. Let's get rid of this 2 and put a 1 there. But to do that, you need to put the 2 out front. So we just do that, and now everything in there matches exactly what we want. So we have 2, this is arc sine. We don't need that 1 over a out front because arc sine doesn't have it. U x minus 2 over a plus c. Is that right? Let me check mine. Yes, that's it. That was short. 1 page. Got it. No split needed. But I guess the lesson learned on this one is this kind of weird setup here with a negative. Factor the negative out. That means you're going to add something in here, but you're really subtracting it because there's a minus here. So then you're going to add that number here. And since this number is positive, you can put it out front, and it's then going to look like your arc sine. And you put that in the back, and everything works out great. So check, check, check. Got it. Well, that's it. I'm going to get this right in under 10 minutes. Hope you enjoyed. Let me know if you have questions. Have a good night.
Made with Doodlecast Pro.